Hello, today we're going to learn about the elimination method. Alright, the elimination method is basically just the addition method. I really don't know the difference between them, but I've just always called the addition method. The addition method was, I heard the addition method the first time this year. But now they're throwing an elimination method at us, and I've always called it elimination, so I believe it's the same thing, but I'm still going to go through the whole process of showing you. So, with the elimination method, alright, like with substitution, when we did substitution, we got something like x plus 3 equals negative x minus 2. After we had like y equals x plus 3 and y equals negative x minus 2. So all we did is we just substituted the y's and we got that. Now with the elimination method, we're going to do this a little bit different. What you're looking for in the elimination is inverses among the variables. What that means is x and negative x, or y and negative y, or negative 2x and 2x, or 4y and negative 4y. Something that when you add them together, you get 0. So in this case, this one is already set up for us, so we don't have to do anything special. I have a negative y and a y. So when I add these together, and remember there's a 1 in front of the x's. 1 plus 1 gives me 2x. This is what people miss a lot on, is you forget that there's that understood 1 there. So 1 plus 1 is 2. Negative y plus y is 0. Then 4 plus 8 is 12. So 2x equals 12. Divide by 2, divide by 2. X equals 6. Alright, now the rest of it is the same exact that you did in substitution and addition. Right. Now we just have to find the other variable. We found the x here. We could have found the y. Y if we really wanted to. It would have been a little bit more difficult, but I'll show you how to do that in a little bit. So x and y, we know our x is 6. So to find out what our y is, we just have to plug that back into both of these. Now you don't have to plug it into both equations. I just do to check myself. Alright, because I do mess up, I am human, and I don't want to mess up. So I plug in 6 where my x would be. And then I just solve. I have negative y there, so I divide both sides by 1, negative 1, and I get 2 as my answer. Over here, I plug in 6, 2. So my final point is 6, 2. So at the point 6, 2, and this and this linear equation cross each other, and that's a solution. So when I do 6 minus 2, I get 4. 6 plus 2, I get 8. So it is the answer for both of these where they cross. Alright, this is our next one. Alright, with the first one, what we had was, it already set up for us to eliminate one of the variables because we already had the inverse. This, there are no inverses yet. I have a 2x and a 1x, and a positive 1 and a positive 1. So what can I do to make an inverse here? Well, I can multiply this all by negative 1. If I make that negative 1, it'll make my inverse here, and I can get rid of them. But I have to make sure when I'm trying to switch something, make it an inverse, I multiply whatever it is by each piece, each term. So negative 1 times x gives me negative x. Negative 1 times y gives me negative y. Negative 1 times 5 gives me negative 5. Alright, now I have my inverse because I can multiply this entire thing to make it my inverse. Alright, so now I combine them. So 2x minus x just gives me x. Y minus y gives me 0. Negative 2 minus 5 gives me negative 7. So x equals negative 7. Now I have to find my y. So I know my x equals negative 7, what is my y equal to? Well, 2x plus y equals negative 2. X plus y equals 5. Plug that in. Y equals 12. All right, so I think it equals 12. Let me just check over here by plugging in negative 7. So I have negative 7, move it to the other side, so I do the inverse operation, and I get y equals 12. So that's my answer. So at the point negative 7, 12 is where these two equations will cross and give you a solution to the system using the elimination method. All right, now here's our third one. It's already set up x, y on both sides. Now, I have to make an inverse because I don't have one. All right, up until now in the other, in the addition video and now in this video, I've only multiplied it by negative 1. This time I'm gonna have to multiply it by something other than 1 to change it. I'll go with the x's here. Simply because I've done y most of the time, so we're gonna get rid of these x's. Now I have 3 and 6. What is the easiest way that I can multiply 3 by something to make it, because I need to make it negative 6 to give me 0. So I don't have to multiply this by anything. What do I have to multiply that by? Well, I have to multiply it by negative 2 to get to that negative 6 so I can get rid of them. So I multiply this whole thing by negative 2. Negative 2 times 3 gives me negative 6x. Negative 2 times negative 4 gives me 8y. Negative 2 times 6 gives you negative 12. Then I just bring the other one over. All right, now I add. So that gives me 0, that gives me 0, and that gives me negative 2. So can 0 ever equal negative 2? No, it cannot. So this is a no solution. Now, if I want to check it, which I will, just to prove that it's a no solution, when I solve both of these and put them in slope-intercept form, which I'll erase that, they'll be the same exact thing. And let's see. Subtract the 3x from both sides. And this is just my check to make sure I didn't mess something up. Divide everything by negative 4. So I get y equals 3/4 x minus, and I'm just simplifying in my head. So that's 6 and that's 4. They both have 2 in common, so I get rid of it. So now let me simplify this one. So I subtract the 6x over, and I get negative 6x plus 10. Then I divide by everything by negative 8 because I'm trying to get the y alone. So y, I simplify that to 3/4 x minus 5/4. And that is what I was looking for. My slopes are the same, and I have different y-intercepts. All right. And these are what are called, they'll look something like this, parallel lines. When you have parallel lines, you do not have an answer. Same slope, different y-intercept. And this is a no solution. Even though I did this problem just so I could show you a no solution and show you that sometimes you have to multiply something other than 1. And there you go. All right, now our last one. We'll go through this a little bit faster. So I don't have any inverses, which is what I need to use the elimination method. But I do have a positive y and a negative y, which helps out. So every time before this, we've always multiplied by a negative something or other. You don't always have to multiply by a negative. right? So what I'm gonna do here is I need to get, so I have 5 and -1. I want them to be 5 and -5. So that when I add them together, I get 0. What do I have to multiply this by to get to -5? Well, just 5. So I multiply 5 by everything in here. This will give me 10x. 5 times -1 is -5y. 5 times 0 is still 0. So I move everything over here. And then I add them together. When I add them together, I get 13x plus 0 equals 78. So 13x equals 78. Divide by 13, so I can get the x alone. And x equals 6. I believe. Yep. Alright, now I need to find my y. To find my y, I plug it into both equations. So 3 times 6 gives me 18 plus 5y equals 78. 78 minus the 18 from that side gives me 5y equals 60. Divide both by 5, y equals 12. So 2 times 6 minus y equals 0. I get 12 minus y equals 0. I have to subtract the 12 to move it to the other side of the equation. And I get, divide by -1, y equals 12. So the answer here is 12. So 6, 12 is the solution for this system. All right, this has been the elimination method. Hope it helped. Good luck.